Yeah, there it is. An online retail company tracked the total number of monthly purchases. In April 2007, there were 3,820 purchases, and in March 2008, there were 4,260. The purchases followed a linear model of the form S of t equals R t plus I. So R would be the rate, and I is what we would call the initial value, I, where S of t is purchases in thousands, and t is months, where January 2007 equals 0. So our sales increasing or decreasing, and by how much? Okay, well, this first part, hopefully it's not too bad, right? We can see that in the earlier month, or the previous year, I guess, they had 3,820, and then suddenly they're pumping out 4,260. So it definitely is increasing, right? So it's increasing. Now, when it asks by how much, you couldn't say, well, I'm just going to subtract those two and then tell you how much. What it's really asking for is a rate. Okay, it's asking how much is it changing on a monthly basis. So this becomes a slope formula type problem. And yeah, we can say, let's see, April 2007, that would be whatever, the 0th month. I don't know. If you want to say it was the 4th month, right? That's April, January, February, March, April. Yeah, 4th month, it was 3,820 purchases. And then in March 2008, so that's almost a year later, April, January is 13. That's January 2008. January, February, March, that's 15 months after January 2007. But it's 4,260 purchases on that, okay? Well, we can solve this, and that would tell us the slope. So let's pull up the calculator again. 3,280 minus 4,260. So yeah, it was now mine shows negative, but the denominator is going to be negative as well. So that's not a problem. Yeah, that's going to be a lot easier to work with once you type it in correctly, like hopefully you guys did. Negative 440, because now when we divide, we simply get 44. Now, this is answering how much, by the way. Well, that's purchases. So we'll write that in. Purchases, if I can fit it. Purchases per month. All right, so it's increasing. Oh, I'll move the calculator. By 44 purchases per month. And that answers that question. Now, of course, this is going to lead to that function that we have up there, S of t equals RT plus I. And we know the R already. That's the 44 purchase per month. Okay, we just got to figure out an initial value maybe to write this in. And the initial value will be however many purchases were made in January 2007, which we'll figure out. So 44 purchases per month. Write out the linear model function with the parameter values. Okay. Well, this is going to take us back to point slope form. So we got y equals m, which is the 44 purchases per month. We got x minus the x value plus the y value. So I'll put in the 44 there. And we already showed that April 2007, well, I said it was the 4th month. But the problem with this is January 2007 is 0 month, is the 0th month, which means February is the 1st month, March is the 2nd month, and April is the 3rd month. So it's actually the ordered pair 3,820. Now, if you think that's confusing, you probably should, because it's kind of jacked up that they used January 2007 as 0, but that's the way they did it, okay? So the actual ordered pair that we end up with is 3 as the x value, and then positive 3,820. I'll make sure I wrote that in right. Yep, as the y value. And from here, we can solve this. Well, we'll distribute the 44. We get a 44x there. And then 44 times negative 3 would be Negative 1,000. My brain's off right now. I'm going to do it in the calculator. 44 times negative 3. Negative 132. Of course, we still got that plus 3,820. So we'll combine those two together, which will tell us y equals 44x. That's okay, we still know that. But yeah, we need to combine these two. So I'm going to go back to the calculator, add a 3,820 to get 3,000, positive, 3,688. Well, that's a pretty good function right there, actually. And we feel pretty good about that function. The problem with this is it says that it wants the purchases in thousands. So I'll get rid of that calculator. It wants the purchases in thousands. Oh, that stinks. So what this means is that we need to write this function, s of t, in thousands. So all this really means as well is that we're going to take each of these values, the rate and the initial value, and move the decimal over 3 times. So this ends up being 0.044x. And x. And also the initial value there, because again this is in thousands, we're going to move it 3 decimals to the right, left rather, which makes it still positive 3.688. And oh, sorry, I used x on that. I should have used a t instead. Well, that is actually the function that it wants. Okay, and again, it may come out as quite confusing because we needed to change all those values into thousands, and we just did. But that is the function. That feels like. Now this part says, what does the model predict total purchases will be in June 2010? Well, we got to figure out when June 2010 is in relationship to January 2007, right? Well, here's something that we should know from this, is that every January is going to be another 12 months away, right? So that means that January 08 would be month 12. So January of 09 would be 24 months. Hence, I don't know, something like that. So January 2010 would be 36 months, right? Well, from there you can count to June. And right here we see February would be the month 37, March, again this is 2010, month 38, April, month 39, May, month 40, and June of 2010. The month we're looking for is month 41. Well, it's the month that we have from this, so we're going to go in and we're going to replace t with 41 in this function right there. So yeah, instead of t, I should put 41 right there. So this equals 0.04, I think we had 44, right? Plus, yeah, so it looks like this one, they approximated those values, but I don't want to approximate right now. There's no need to. So I'm going to put this into the calculator, which will tell me, what is this, the purchases, right, that we would expect in June 2010. So let's go to the calculator. Now from this I get 5.492. But again, this is still in thousands, so we just need to replace this with thousand. Just multiply it by 1,000 if you'd like. You'd get 5,492 purchases. And again, this is for June 2010. So there's our formula, and we got to figure out what month and year does the model predict sales will be 5,780. And again, it's still based off of January 2007. Now this is asking purchases, right, which is S of t, so we're going to replace that with the 5,780, and this becomes an equation that we can then solve. So we would subtract 3.688. Oh, yeah, and seeing this shows that we need to change the 5,780 into a decimal, which would be just divided by 1,000 or move the decimal 3 times to the left. You get 5.780, and you don't need that 0 there. So now subtract 3.688, and let's see what that comes out as. Yeah, so we subtracted that, and we get 2.092 equals 0.044t. And then, of course, the last thing we'd want to do is divide both sides by 0.044 to make that a phantom 1 there. But yeah, if you do it one side, you got to do both sides. So t, this is the month, right? 2.092 divided by 0.044 in my calculator. And, well, maybe we'll round it. It's 47.54. So we'll just round this up into 48 months, okay? So say t equals 48. So this is 48 months after January 2007. Well, 48 is a nice round number because every year is 12 years and 48 is a multiple of 12. So to figure this one out, we'll just add 4 years to January 2007, which puts us at, in actuality, January of 2011. So that is when we would expect there to be 5,780 purchases based on this linear model. And you would hope that a business that's been around that long would maybe have a little bit of exponential growth, at least a little bit, you know what I'm saying? But for what we have, that's the answer that we get.